Hello guys. So thanks to join my session. I hope it will be really good for you. And before we start, I wanted to speak about our topic. So what I'm going to show you right now, and who we are, by the way. Please hands up. Who are heard something about the Dynatrace before this conference? I don't know. It's good. It's good. It's good. So who we are? My name is Vlad. I'm basically from Ukraine. Sorry, my language is not. My Lithuanian language is not very good, but I speak in English now. But well, we are like a distributor of the Dynatrace. We're representative of Dynatrace across all Baltic countries. So I wanted to tell this next 45 minutes about what we found using our solution in our project, my project and my colleagues' project across my country, my Ukraine country, Baltic countries as well. So, but once again, before we start, as you might heard, you still have a chance to get a job. Yeah? If you will scan this QR code or go to the apnchallenge.eu, just put your site name and you make your forecast for the response time, how your website will open, how fast it will open it. If your forecast will be close enough to real response time, and you will place the first place, so you will get a job. But of course, it will be around 5 p.m. somewhere near our booth there. So, by the way, you still have a chance to scan this QR code as well. So, do you like this car? Yeah, everybody likes this car. So, it's designed to be extremely fast. It's designed to be extremely safety. And as we are developers or as we are testers, we are rely that, and we hopefully and we believe that our code of our application will be extremely fast at this car. But something happens. Something goes wrong. Maybe some hole on the road for this car. Shit happens. And shit happens with our code. For example, yesterday when I prepared this presentation, I just had a really bad experience with one Microsoft solution. Do you know Office 365? Yeah, everybody knows Office 365. And I tried to log in to my account using web browser and using Chrome browser. And you see what's happening? Do you see? So I cannot log into my page because it's trying to log in and once again and once again and once again and once again. Okay, I'm IT guy, so I just opened another browser and I just log in. But if I'm not IT guy, what it will be looks for me? What the hell? Huh? So maybe if it happens with the e-commerce side or internet banking side or other stuff, I will switch to another one. But it's my mail, so I need to open my mail. And nobody wants, from the developer's perspective, to have such situation with your end users. Because you can see like this stuff and real person, nobody wants to see this outage unless you're working for Microsoft or for Google stuff. Because downtime leads to this picture. Do you know where this picture came from? Anybody knows? No? Facebook. Downtown Facebook 2012. So this is a real picture from the war room on the Facebook. So there are sitting a lot of guys, a lot of developers, a lot of DBAs. They're trying to find a solution. What happens? Why it's downtime? And of course, downtime can go due to such stuff. Our page, Apple outage costed developers about 125 million per hour. It's huge money. It's really huge money. Of course, we are developers, and we can be like this kind of hero. Yeah, I'm James Bond, a really cool guy, so I always get what I wanted to get. So I really go to my target and all my goals 100% of the success. But it could be another hero. Do you know this guy? Yeah. Who is this guy? Yeah? Huh? Yeah. And I'm testing my product in production. And there is one really big company, and you know it, that's testing the code in production environment. Do you know this company? Come on, guys, you're all social guys. Everybody has maybe a account on Facebook, Twitter, and all that stuff. Do you know which company testing the code in the production?
Google?
Could be. I don't know about Google, but I definitely know about Twitter. So they're testing their code in the production environment. Okay, so let's switch to some journeys, and we can say that 63% of the organization spend 20% of their time working on performance issues. The bad thing that's around 40% of developers, 40% of developers spend on the dry edge, stealing their time from focus and other things that provides you time to innovate something really cool. The good thing is 80-20. Do you know 80-20 rule?
Yes.
Yes. So I'll skip about this. And this, if you are working with 80-20 rules, this is really good way to make your code really, really good. Another 80-20 rule from Steve tells that a lot of time spent on front end because downloading a lot of static contents like PNG files, CC, etc., etc., etc. But in this case, the more you have users hitting your application, the more changing the behavior on your front end or back end side. This is public information, just Google. It's really, really nice. Okay, so let's switch to the use cases that I hopefully help you to avoid your software fails. Okay, I will provide 3 pictures, and please tell me what's the common between of them. The first one, second, and the latest one. Any ideas? Pushing without a plan. What do I mean? This is a screenshot from monitoring of the browser from one American Super Bowl website during the ad campaign. The idea is that somebody just pushed a lot of ads to the websites, and nobody cares about the size of the all contents that user will be downloaded. Okay, what we can see here right now. First request, 6 milliseconds, extremely fast. Total size, 20 megs. What the hell? Okay, and 434 resources on the page. CSS files, image files, a lot of stuff. Is it really good to push a lot of stuff to the one small page that users will download through the mobile broadband? It's not a good idea. Another one. Everybody knows Barack Obama, hopefully. And he creates one service, okay, healthcare. The bad thing that developers creating the JavaScripts put it a lot of comments here. Comments are good for developers because the comments will help them to understand what this specific part of code will help or what it's doing, but not of the 80% of all the size. It's really, really stupid. So please, just be careful with the comments. Another part, 5 icon. Downloading 5 icon for 1 and 2 seconds is extremely abnormal because of the size. And really heavy CSS and JavaScript. So, what's lessons learned? No excuse for developers not using the browser built-in diagnostic tools. Everybody knows F12 for the Chrome. Please use it. It will help you to see how your application, web-based application, is working. How much static contents do you have? What the average size? What's the average speed of downloading them? Try to use this. And testers definitely should use the same tools as well as the developers, because they will see the total same story. Again, you can use another stories like page speed, write slow, or tools like Dynatrace. And of course, the level up is automated testing, they are not check tools as well. Okay, so 4 things. Number of resources, always check number of resources, number of domains. If you have really huge application, with a lot of contents, try to use CDN. Akamai is not so expensive as you might think. And page load and size. Try to reduce the amount of the resources that you are downloading. Okay, another 3 pictures. First one, you see that there is nothing here. Why? This one, and my favorite one. Yeah. Ideas? You're right. Not every architect makes good decisions. So, my colleagues from Poland had a nice story, a nice project. They shared this information with me. Online room reservation. So everybody maybe use Exchange. Then you plan your meeting. You can send a request to the room. You will see the availability of this room. But more organizations use like a web-based solution to get the availability of room. Okay, so when the people trying to get the availability of room, HTML takes like 1 minute or 2 minutes to render. And during this rendering time, during this invocation, there are a lot of time spent on the GC. Okay, what do you think about the developers? What your developers? What are you thinking? Where you start to dig in? What you start point to investigate these errors? Any ideas? Any ideas? Basically, web server, application server, database. Out of memory, could be, but could be not. Developer solution, GC tuning, with memory, and probably something wrong with the DB size. Results? War room. Months of finger crawling between the application guys and the developer and the DBAs. And let's switch to the code what developers built to check it. Okay, and this code creates results like 41 seconds. Not so fast, but DBA tells, okay, I see the SQL statements that came from your application. And the execution of these SQL statements is around 1 millisecond. It's extremely fast. So DBA tells, I have nothing, I have all properly work. And of course, we see a total different situation. One guy see, okay, I have this situation, these values. Tester or developers, I see these values. The idea is that you need to hide overview of this total different story. So in this case, we see, okay, I have an application server, and during this invocation, 20 seconds was spent on the Java tier. But during this execution, high CPU and high memory usage to keep all data in memory. Why? Because it invokes 25,000 calls to the DBAs per one single request. Is it good? How do you think? No, it's not good. Let's switch to the database part. Okay, we have tons of the SQL statement, but DBA was right. They are extremely fast. Okay, 2 milliseconds, 1 millisecond. So DBA will tell you the truth. So I have a lot of statements, but they're extremely fast. And of course, you can see the one single request query executed like 12,000 times. One single request. Why? Maybe it's by design, but it's really ugly design. Another story. This is a story from my project in Kiev. Customer using rich client based on the .NET part. And then they try to push some button. It's spent, okay, how much is it? A lot of milliseconds. A lot of seconds, by the way. Okay. Why? What happened? We see like 500 or 600 invocations to the server component and almost 1000 to the database. Almost the same story, but we invoke like stored procedures. They're stored on the database tier. Okay, we have list of them, we have response time for them, we can see the execution, acquisition time is good, and of course execution by transaction. Maybe it should be work like this way, but do you know which parameters or bin values passed to your database with one single request? So statement could be the same, but parameters will be different. So try to carefully look inside your application code. See that the same store procedure was the different parameters, and of course the response time is quite fast. So lesson 4. Please try to know what your code is doing, and always challenge the developers and explore a lot of tools to avoid such situation, like a SQL profiler or a login option for framework like SAP.NET or other tools like our tools. Okay, so what we learned: amount of SQL execution, amount of same SQLs, and of course connection acquisition time. So try to check the time was spent for your application to connect to your database. But we'll speak a little bit later about it. Another story. Are you familiar with this interface? What is it? It's WebSphere, IBM. Do you like IBM WebSphere? Who is developer on Java application? Okay, so IBM Java is IBM Java, but IBM application server is IBM application server, and one thing that one service log exists for all Java virtual machines on the node. We have one node and we have 10 virtual machines on the one single node, and it will generate one single log for all 10 or 20 JVMs inside one single node. It's quite a lot of time was spent on this API to write the information to the log files. And of course, you need to get information who invokes such amount of time to write this data inside the one single log file from all these 20 or 100 JVMs. Try to not enable this stuff in production. Another my favorite story that I spent a lot of time with my customer, that's developers, forgot to disable debug mode and they just deployed this application to production. What we saw, 70% of the response time was spent on the log4j. By the way, it was the same WebSphere. This is a really bad picture, because you see this? Tons of milliseconds. By the way, it's like 5 or 6 minutes. When the client pushes some button, he needs to spend like 5 minutes to get the data or get the response time, get some feedback from the application server. He would go to take a beer or take a coffee, and when he gets, he will still need to wait for it. Okay, and we investigated that a lot of time was spent on the log API. We just speak with the developers, and they tell us, oh, sorry, we forgot to disable debug mode in the production application. When they disable this debug mode on the application, do you see how much faster it was increased? It was like 6 minutes, right now it's like 1 minute, no, 1 minute response time. So please disable extended or debug logging before you are going to release your application to the production line. So there is it. Okay. Lesson learned: time spent in sync logging, number of log messages, and try to use information about exceptions, amount of exceptions that you have right now. Okay, now there are 3 different slides. Everybody knows this guy. Maybe somebody knows this guy and this guy. Any ideas? This guy was developed really good. But everybody knows this story, you see. Why? Because deployment somewhere, some piece of deployment went bad. What I'm speaking about? Before we are going to release something into the production environment, we need to test it. Okay, in our story, what do we have? We have some web requests that comes to the Apache proxy, comes to the other components of our application, but the idea is that it was spent for this specific guy, maybe it's external application that invokes our components. It was spent like 42 seconds. Okay? And this specific guy invokes 1064 times for one single Oracle instance. It was a test environment. But when they release it in the production environment, they saw the total different story. Yeah? The response time 8 times slower for this specific web request. Have additional 3 times more SQL statements to the database. Why? For the test environment, they saw that a lot of times were spent on the web request API. It's a normal for web request. That is, I.O. was spent on the web request API. But in the production environment, they saw a total different story. A lot of times was spent on the Hibernate, and I.O. for web request doesn't never show up. Why? We can see the top contribution plus get interface and OH specific methods were invoked. There were like 1,000 of calls to find the item by each specific part of code. And another story, the top methods related to the XML processing. The same thing. 70 seconds was spent with this guy, but it was called by these 2 guys. So class loading is triggered through the custom monkey and so on and so forth. Lesson learned. Please plan enough time for proper testing. Testing before we go into the production. And only test that really ends up in the production. So if you expect some amount of users, try to get the test as much possible closer to that your expectation. 2 metrics that you need to consider, like time spent in API, number of calls to the API. Next 3 pictures. I think you got them. By the way, I have never received such amount of traffic jam even in Kiev, so it's quite huge traffic jam. This one and this one. Ideas? Yeah. Incorrect sizing of pools and queries. Okay. What do we have here right now? Online banking, slow balance check. Then I'm trying to see how much money I can spend to buy a beer in the Vilnius. I see from the backend perspective that 87% of the time spent on the IIS, on the web server, and it generates like a 600 SQL execution in the database. So the idea is that 87% of the time spent here, so I need to dig to this specific web server. Maybe something wrong with the IIS. But when we drill down, we see a totally different situation. You see that we say web request, execution reader, asynchronous location, and there is that 32, these guys, and IIS wasted 87 seconds to pass control to the thread on the ISP.NET. So, elapsed time tells us when the method was executed and other stuff, but from the database perspective, every SQL statement is executed in its own connection. Is it a good idea? No, it's not a good idea. And to execute one single statement, I need to connect to the database once, over and over and over again. This is not the best practice, I think. More, same SQL statements as I told previous part, executed 67 times without no preparation. It sucks. Okay, lesson learned. Try to work with your pool sizing for your application components, and please establish the DB connection pool. The big connection pool is really, really good. Another story from my own project. You see that from the database perspective, it was spent almost 1 minute to establish connection to the database. But after it established connection to the database, each single query was quite fast. Why? Because connection pool was totally saturated. This is a good thing that you need to extend your application connection pool. Okay, 3 metrics that we need to consider. Idle versus busy threads, number of SQLs and requests, and number of get connection per one single transaction. So, overall, remember new metrics when testing your application. Number of images that web browsers of your end users are downloading. Number of redirects, number of sites of resources, SQL execution, same SQL statements, items per page, adjusts per page. By the way, who's using AngularJS? Good. Another thing, time spent in API, number of calls into the API, function errors, and other stuff. There are a lot of metrics that you need to consider before you are going to the production and developing your own code. I have tons of projects and have tons of examples which where the issue could be in a specific situation. If you have any questions, just join me on my booth. And each week, Dynatrace provides online WebEx where they can help you to answer all your questions regarding your application, about the performance of your application, about the framework that you're using in your application, and other stuff. Of course, you can tell, oh, yeah, okay, so we're a good guy and nobody uses this tool inside your training function, but you're not alone. We have one good company, developers company. Do you know Alma software company? Yes, good. So, they are using Dynatrace for development purposes, for the development Java.NET application to increase the quality of the code, the quality of the service that they provided to their customers. So, and of course, you still have a chance to win a drone if you scan this QR code and put your necessary details, and hopefully you will get that drone. Of course, in a few minutes. And as you might know, we have after party. Yeah, maybe we'll have some beers tomorrow. And please, do not fail to deliver on Friday tomorrow after our after party. Questions?
Any questions? Actually, I was smiling with the presentation because I lived with dollar problems for almost 10 years, and I have overcome this problem. And I agree with you regarding challenge developers, right? But what about performance that is more related to not delays, but waits and queues? Sometimes you are measuring them by just putting requests in a queue, right? Mm-hmm. Or sometimes you are measuring what the time spent in by adding waits. Mm-hmm. Do you have any measuring technology for this kind of performance?
Yes, please join our booth, I will show you.
Okay, thank you.
Thank you. More questions?